My name is Uday Kumar. Let me write it down. I should have put it on my first slide. So, and that usually, phonetically, that's Uday. I am a professor in mechanical engineering at the university. I have been teaching courses on energy for about 10 years now. And I have a senior course that I teach that is on energy systems design. So how do we go about designing energy consumption devices and production systems in light of the fact that we are coming towards a new paradigm for energy, right? Fossil fuels being phased out and other fuels coming in. What are the prospects for those? And can we do it? Can we actually power the world with non-fossil fuel sources? And the answers are quite surprising. They're not the conventional thing where people say, oh, well, if we only switch to wind energy, we could just do it with all the pollution and our problems will go away. Or if we could only do nuclear, everything would be fine. It's not as simple as that. And then, there is a whole issue of global warming that has to be discussed in that context, right? For example, people may say things like, well, we know that we have to switch away from fossil fuels, but if we could just do this for another 50 years, then by that time we could have figured out something that would help us get out of trouble, right? And that's the wait and see attitude for something to come along. Unfortunately, that would be a great way to do it. That kind of a transition would be a great way to do it if it were not for global warming. Because we cannot wait for another 50 years. We cannot even wait for another, actually we cannot even wait for another 5 years. We wait for another 5 years, we're already over that period where we could potentially get out of the harmful effects of global warming. And so these are the main issues I deal with in that course. And I deal with it in the context of having young kids in my class who are going to be engineers of the future. And I sort of throw cold water on them in the beginning of the course, and that's what I'm going to do to you guys today, is to talk about the issue. What is the issue? What is the situation we are facing, and why are we in this situation? And then maybe in the next few lectures I will talk about what could possibly be a way to deal with this. Okay? And the choices are very, very difficult. They're not easy choices to make. Okay? It will require all of us to change the way we live. If we expect that we're going to deal with this problem, living the way we do, that is a pipe dream. Okay, so everyone has to make very, very significant choices in their lives to change. And it's not as simple a change as saying, I'm going to switch from my light bulbs to the more highly efficient ones, okay? Or I'm going to just drive a Prius instead of a large vehicle, okay? It's not as simple as that. It's got to be much deeper than that. Okay, the way we view the planet has to change. Our interaction with it has to change. We cannot treat the planet as an infinite pool of resources that has been created for our use. We have to treat it as an organism that we live with. And how to do that is a challenge, I believe, that is going to change humanity in very good ways. Okay, and it's time. It's time for humanity to grow up and start acting like responsible global citizens. Okay, so that's the connecting of the dots that I want to do. I want to connect how each of us, the way we live our lives, connect to the larger global picture of warming and its consequences, I want to connect how everything we do, how long we take showers, whether we walk or drive, what we eat, what we drink, and just the way we conduct our everyday lives, how it connects to this. Okay, so that's what I want to do. That's what I mean by connecting the dots. It's not just one single piece of the puzzle, but the entire puzzle has to change. So, as the lead in to this, I want to, have us already contemplate at the beginning that we live like kings, actually. If we really think about how people lived, probably not in the 20th century, but in the 19th century or earlier, right, before steam power. If we just think about how they lived, we live like kings. And there is a particular numerical reason why I say that. Unfortunately, as an engineer, I'm going to throw numbers. Okay, this is just, and sometimes it can be a little unnerving. So another thing is, I don't intend for this to be a lecture. I would like it to be a discussion. So anytime you have an issue, just please interrupt me, because otherwise it never tends to be a good exchange. Okay. And I hope to learn actually from you guys a lot as well. It's not just what I know, but what you guys know, because you have a different perspective from the students that I normally teach, and I'd like to know what your perspective is. Okay. Why do I say that we live like kings? If you think about it, in the United States, every one of us consumes an energy equivalent of 10 kilowatts, at the rate of 10 kilowatts. Okay, this is the rate of energy consumption per person in the United States is 10 kilowatts. To some people that doesn't really mean much. So what does that mean?
That's the unit of time.
Yes, so energy consumed energy consumption rate per capita. Or power consumed.
Is that per day?
This has a unit of power. It's power consumed.
I know, it's per year.
No, I should replace energy with power. Power consumption. Power is energy per time.
For our lifetime?
Yeah.
Sorry?
For our whole lifetime?
What is the
No. Okay, so let me clarify that. I immediately realized that I shouldn't have put that number there. Okay, so this is going to be rough because I've not done this for an audience. So it's power consumption. I shouldn't say energy. That was the wrong word. It's power consumption. So what does that mean? That means that at every instant of our lives, we have 13 horses at our command. Okay, the power equivalent of 13 horses at our command, or 100 humans working for us all the time, 24/7, 365. 100 human beings. So imagine that we are sitting here at the moment, right? You and I, everybody is here. Unbeknownst to you, there are 18 people, 19, 20 people in this room. Unbeknownst to us, in the basement, imagine that there are 2,000 human beings pedaling furiously on bikes, generating the power required to make our lives possible. Right? 2,000 human beings just to make our sitting here possible at this moment. You can imagine that a king, even a king in the old times, possibly had order of tens of manservants, or people running around making his life possible, royalty, king or queen, right? So we have 2,000 people now, all of us, working away furiously in the basement. And if they tire out, then there's another replacement. There's this whole band of people coming in, armies of people working for us. Okay, in that sense, we live like kings. And you might think, oh, it's just the United States. The United States is actually number 7 in the list in energy consumption per capita.
Really? You have a list?
The list includes Bahrain, which is number 1, Qatar, Canada, Australia, and some other riffraff countries that are...
Australia?
Mm-hmm.
I thought they were under-consuming us.
No, I'll show you the data. Australia and Canada are ahead of us. So in that sense, we live like kings. Okay. But living like kings has consequences, right? So if you look at how the US and what the energy consumption looks like in the last 30 years or so, this is taking 1970 as the baseline, right? So imagine yourself in the 1970s, okay, and that is this 0 point. Okay. Between now and then, if you look at this gray line, that is the GDP of the United States. So GDP of the United States has sort of doubled in the last 30 years. Okay? And if you look at this is the driving miles, the number of miles driven by a person. Starting from 1970, it has increased by 155%. Right? So people are driving a lot more. Okay?
But it's my understanding that China has surpassed the U.S.
Yes, we are coming
in
to
energy consumption.
Yes, absolutely. Yeah, China is number one in total energy consumption, but not in per capita. Per capita, they are still 1/4. Per capita, by per capita, let me clarify. Per capita, I mean per head, per person. Right? China is number one. They're also the biggest polluter right now. But per capita, per person, we are still 3 or 4 times as large as China.
The graph doesn't show per capita, does it?
No, this is just the
Population as a whole.
Yes, population as a whole.
Yeah.
Mhm. Yeah. So now, if you look at energy consumption also has gone up, not as much, if you notice, as GDP growth, right? And herein actually lies another little fallacy that people don't pay attention to, which is that growing your GDP does not require the same amount of growth in energy. You can grow your GDP while actually decreasing your energy consumption, which is what has been the case, for example, in Denmark. Okay, Denmark's energy consumption has fallen in the last couple decades, all right, but their GDP has continued to grow. Okay, so those are disconnected, all right. So you might ask then the question: how can your GDP grow if your energy remains flat? Energy consumption remains
What
flat.
about Denmark's population?
Well, the population is held steady in Europe. It's not terribly, so United States, in the past 30 years, the population has gone from 150 to about 300 now million, right? So United States has probably increased considerably, but not in Europe. Okay. And if you look at US population, again, it's basically gone. It's increased by 38%. So that's the US population. That's kept in sort of line with the energy growth, right? So energy and population have increased quite steadily. And actually, and this is another thing that one has to think about, emissions have dropped in that period.
Good for us.
Yes, and why? Primarily because of the EPA. Primarily because of the EPA. So if people blame the EPA for lots of things, but without the EPA, that would not be the case. Okay, so there have been, the Clean Air Act and all this stuff has had an effect. And in fact, our emissions are quite low. Okay, and I'll talk about the reasons for that later also. The main reason why our emissions are low is because we have more efficient ways of producing energy. And utilizing energy, correct? Automobiles have gotten more efficient, correct? And industrial processes have gotten more efficient, and so on and so forth. So there has been an improvement in efficiency. So this is sort of the picture in the United States. We should be happy about some of these things. Okay. Now, of course, the flip side of the coin is that while the United States has been growing and so on and so forth, if you look at the United States with respect to other countries, how does the United States shape up? Okay, so this is a question that one might ask. For example, let's take several categories. The blue here is developed countries. So you can think of this as Europe primarily. Okay? And this yellow sliver is the US. And this brown sliver is the developing countries. So primarily, you can think of that as being Asia and Africa. All right? So this is US, Europe, Asia, and Africa. Look at the population. Okay? As a percentage of world population, the United States is about 5% of world population. The developed countries, developing countries, Asia and Africa, are about 80% of the world's population. Okay? And Europe and so on is about 20%. Let's look at the waste generated by each of these segments of the globe. If you look at the hazardous waste generated, the United States is 72% of the hazardous waste generated in the globe. 5% population, 72% of hazardous wastes. Okay? And this is the other developed countries. Now that actually is not a good picture because the other developed countries, which have a good standard of living, are generating 18% of the hazardous waste, while the United States is generating 72% of the hazardous waste.
Is that due to they use more nuclear power than we do?
The only country that actually uses a significant amount of nuclear power is France. Okay. The rest of them have nuclear power, but increasingly they're shutting it down.
What are they doing?
Good question.
So your bar chart, your histogram there, the top number is the total of that column.
The total of that column.
Okay, I got it.
Yeah.
All right, thank you.
So, and the developing world has contributed 10% to the hazardous waste, right? So this immediately you can think about this, and this is part of the connecting the dots. So if you think about it, if the United States goes into, let's say, a discussion of how energy should be done in the future, or how global warming should be handled by, let's say, China and India, right? And it says, no, you guys need to cut down on your emissions. What do you think people would say in those countries?
It's our turn now.
You should talk.
So,
They would say.
and what happens then is the United States pulls out of those discussions immediately, right? Which is what happened with the Kyoto Protocol. For
They
instance.
probably think we have no business ever criticizing them about it.
That is possibly one of the things they could say. It is very sad, okay? But one should bring this into the discussion of any of these kinds of things. It's very uncomfortable for us, right, living here.
What is the basic reason for the hazardous waste in the US? What are the main contributing factors?
I'm coming, if you will,
Okay.
I will come to a very deep discussion of that later. In fact, most of what we're going to discuss is going to try to answer that question. If you look at energy consumption, the United States actually is not doing too badly in terms of energy, right? It's about 24% of the energy, 5% world population, but 25% of the energy consumption of the world. And then this is the rest of Europe. And if you look at all the developing countries put together, Asia and Africa, they are pretty much the same as the United States alone. Okay, pretty much the same as the United States alone in terms of their energy consumption. Again, this when the United States goes and talks to China and India about cutting down their emissions, this comes into the discussion. Right? And if you look at fossil fuels, the United States consumes about 25% of fossil fuels, of oil and coal and natural gas in the world. Okay, so this is so you can see that globally the energy consumption, emissions, all of this is kind of lopsided, right? So the United States is the 800-pound gorilla in the whole act. Okay. And if you look at emissions, again, this is sort of telling you, giving you the same picture in a different form. You look at the US and how it's changed over the last 200 years, from 1800 to 2000. It started taking off at this point, and then there's another takeoff here. If you look at these curves, the curves are sort of, have a low slope, as we call it, and then all of a sudden there's a high slope, right? A rock face. And we can track what these are. What is this here, this slow takeoff point? 1850 is when the steam engine, about then was when the steam engine was invented. Okay, so the locomotives came in somewhere in this period. Okay, coal-run locomotives, and then oil and natural gas. So oil and natural gas somewhere in the 1900s. Okay, the automobile comes in. All right, and then this the part of the graph is automobiles taking off. Okay, the war here, right, and then out here there's another steep increase in about the 1970s. What do you think that is?
Baby.
Baby boomers, but in terms of energy consumption, that is
Air conditioning.
air conditioning. Okay, that's air conditioning. So that's air conditioning right there. And then of course you see the oil crisis hitting us there, right?
Yep.
And then of course afterwards, once the oil crisis goes away, business as usual, back again. Okay. So air conditioning, you might think air conditioning really, why did that make so much of a difference? Air conditioning, or conditioning of buildings, takes up 40% of the energy in the United States. So that is that huge chunk right there.
What happened to the former Soviet Union? Suddenly, when the wall came down, they plummeted in carbon emissions.
This is actually I have no idea why that happened. Maybe their economy went south. I'm not sure.
They stopped manufacturing things. They did.
Their
and
economy
they
did,
had
yeah.
a hard time.
So this also reflects economic downturns and stuff like that. I mean, I'm not sure exactly. I shouldn't say what I don't know. So I don't know exactly what that is, but it could possibly be that.
They're freezing it out.
Possibly. Well, actually now they're warming up. Even in Siberia, you can actually grow things now because of global warming. So this then, the couple of points I wanted to make. We live like kings, okay, and that living like kings takes a lot of energy, and taking a lot of energy in and consuming a lot of energy has its consequences in terms of emissions and footprint. Okay, so the operational word for me is footprint. So how large a footprint are we leaving on the earth? So the question is, what will the future bring? What's gonna, is there gonna be something that's gonna stop this trend? And what can we expect in the future? If you really think about what is happening in terms of world population, right? World population has been increasing steadily. It was about 6.6 billion in 2007. It's about 7 right now, right? We celebrated with great fanfare the birth of the 7th billion baby. And if you really think about where we are right now, it was supposed to be 7 billion at 2013. These were projections. Okay, but actually we have outstripped that. In 2011 we were at 7 billion, correct? And it is expected that this curve is going to flatten out and that we're going to top off at about 10 billion in about 2050 or so. 9 to 10 billion, somewhere in that range.
Well, isn't it supposed to go up another billion by 225?
Right. So the projection at least is that we will be at 9 to 10 billion by 2050. And that's the flattening of the curve.
Why is it going to flatten?
We don't know.
But
That's
who
just a
said that it
projection.
would?
Oh, well, we don't know. Again, these are just projections. These are based on
Projections.
growth rates in different countries.
Could it possibly be because people are becoming more aware of the situation? Younger people are not having as many children?
Possibly. At least in the West.
Yeah.
Least in the West. I'm not sure that is the case in Asia or in Africa for that
They're
matter.
not having children, but they're using a lot of energy.
Correct. They're also
Computers and
per
stuff.
capita. You're right.
Cell phones.
And if you think about India, where I go, I grew up in India until I came to this country about 25 years ago. And in India, in the cities, it's about 1.8 kids now per family.
Really?
Yeah.
What is it in rural areas?
In rural areas, it's about 4. It's still about 4. But it's down from
That's
about
down.
it's down from about 6 or 7 50 years ago. So it's coming down, but it's still quite. It's not replacement. We really need to be at replacement or below.
And they don't have draconian laws about it.
No, they don't have draconian laws about it, but they have draconian measures, personal measures about it.
Gender selection.
Sorry?
Gender selection.
They have gender selection and other such things that are, yeah, that are not nice.
So China was on the right track.
Sorry?
So China was on the right
China
track.
was on the right track, yes, in terms of its population. And that's why India actually is going to outstrip China in the next 5 years or so in its population.
Couldn't food have a possible impact on that?
Yeah, the food will definitely have an impact on that.
Yeah.
And well, we'll come to food later on in maybe
Okay.
the third or fourth lecture. So there is no way we can feed 10 billion people with current land resources. So the alternatives are to either go to genetically modified plants or to chemical fertilizers. But chemical fertilizers have only so much that they can do. So yes, food will definitely be a limiting factor. It already is in places in Africa. So yeah. But however, the people have calculated that we could support 15 billion humans. The Earth can support 15 billion humans. That's the carrying capacity in terms of food.
Really?
Yes. So
If we all eat plants and not animals?
right. If we all eat plants.
Yeah.
In fact, we'll come to that. It takes 4 times as much energy to grow an animal per calorie consumed as it does plants. So, and land and water usage is enormous. It's not even close to 10 times is what I would say, land and water. So, with all of that thrown in, it is possible, even with organic agriculture, to feed 15 billion people. So this is something we are facing. The population is going to grow, and that's sort of inexorable. We really can't put a stop to it in the next 50 years. There's no known mechanism to stop the population from growing like that. Okay. So then the question comes in, and this is what I emphasize to my students in engineering, is the concept of sustainable development. You've all heard about sustainability and all that stuff. So what that means is that how do we continue to progress as human beings, whatever progress means. I don't know what that means anymore. But how do we continue to carry on doing whatever we are doing, which also I don't know what we are doing, while also making sure that our kids and our grandkids can continue to live. If you think about the Native Americans, they famously said that whatever they do, they should do in such a way that 7 generations can live happily, right, to the earth. I mean, that was their credo. So currently, I don't think we are even at 2 generations, because there's something called the carrying capacity of the earth. So the question is, what is the carrying capacity? What can the earth take? Right? Because the earth is not some mechanical thing that is an infinite resource for whatever human beings desire. I don't know of a single spiritual body of work of any nation or community around the world that tells you that you can have whatever you want to your heart's desire. Right? I mean, I think we all know that there are the 7 deadly sins, and one of them is gluttony. So clearly, we cannot have whatever we want. Okay? That is a very foolish thing to aspire to. So one has to ask, what can the earth support? Okay? So the current calculation is that the way we are living right now, right? We are already at 1.3 times earth capacity. Okay, what does that mean? That means that we are consuming about 30% more than the earth can really sustainably produce for us. Okay, what do I mean by sustainably produce? It means that 30% extra we're getting from earth is not something the earth can replenish.
When you say we, are you talking about North America or the world?
Humanity. I'm talking about humanity.
Everybody.
Yes. Because I'll show you about India later also, where I'm quite familiar
There's
with.
quite a disparity between the ability of each of the continents to do what you're going to talk about.
There's a huge disparity in what they can do, and there's a huge disparity in what they are doing.
And
Okay.
what the dire effects will be too. I mean, I think in North America, we tend to be optimistic about what our
Right.
capacity is.
Right.
And I think maybe, are we crazy? Or maybe
I don't think we are crazy.
are we a little bit right?
No, we're not right. It's both. I think we are a little bit crazy and a little bit right also. But it's actually much more nuanced than that. I think that, at least in my view, and this is of course my opinion, but it's based on looking at different situations. I think it is that a young nation always has a greater amount of hubris than a nation that's been around for a while. And I think that when you come into a new land that is unexploited, you think that there's infinity at your command. But then when you get proscribed by the oceans and you get proscribed by the forests and the mountains, and then you realize this is the amount of land I have, and this is all the richness that I can actually, in reality, have for myself, right? Then reality hits you. Okay, so it's a question of the United States growing up and hitting that reality. Other countries have hit it already many times. And there are civilizations that have completely disappeared from the face of the earth because of their overexploitation of the earth. I mean, we know that. Okay. So there is a reckoning that is coming that we have to deal with.
I mean, right now,
All things are connected, so whatever we do impacts other countries, other states, other people.
Right, and that is the theme that I'm trying to get to, is that what we do here actually affects to a significant extent what is happening in India or Africa. And I'll show you how later.
Yeah, but what they do there also affects the world.
Absolutely.
As an example, it's population.
Right.
That
Absolutely.
to me is the overriding issue.
Absolutely. It affects your economics. It affects our food supply. It affects our price of oil. Or all of this is affected now clearly by China and India and their growth rates.
I think currently we're so rich as far as the country goes that we are taking resources from other countries so that we are not totally dependent just on what we have.
Correct.
And I include Canada and Mexico
You're right.
in our country kind of thing,
Yeah, absolutely.
economically at least.
Right. I will show you the data on China and its CO2 emissions. And a lot of it is because of its exports to the United States.
Okay.
About 13% of its emissions are because of exports.
Hmm.
So we have exported away, you can think that our emissions are flat, but we've exported away a lot of that to China because we're not doing manufacturing anymore. The graph that showed the emissions kind of flattening out, that's because a lot of our manufacturing is abroad. There's only so much emissions that people will put out with computers. That is primarily a lot of what we do is services and stuff like that. So the carrying capacity is an important concept, and we are at 1.3. The idea is that if China and India have the same consumption patterns as we do in the United States, we'll be at 7 Earths. Okay.
did you say 7?
7.
7 times.
There's actually a whole organization called 7 Earths, okay, that talks about the carrying capacity when India and China are consuming as much as the United States.
And they want to.
They want to, of course they want to. Oh, yes, I will show you data on this. Okay, in India, it's not unusual for a person in the city to have exactly the same kind of lifestyle that we do. So it's all coming to a head here. So when we talk about the future, what kind of a scenario are we looking at? Are we looking at possibly extinction? What are we doing to ourselves? Because this is the only planet we have, right? There's no other one that we know of at the moment that we can colonize. And Stephen Hawking, when asked the question, what is the future for humanity? He said the only possible future is for us to leave the planet. Okay, and So that's what his notion of things was. But I'm not sure that that is necessary yet. So the question is, what could possibly force changes to the way we live? And I want to show you this video by James Hansen. I don't know if you're familiar with James Hansen. James Hansen was NASA's chief scientist and was primarily responsible for gathering the data that showed the warming of the Earth. And he was actually an Iowa graduate. Okay, so he's an Iowan from somewhere up north in Iowa. I forget the town, but I will show you his video, and it must hopefully it will resonate with you and what I'm talking about.
What do I know that would cause me, a reticent Midwestern scientist, to get myself arrested in front of the White House protesting? And what would you do if you knew what I know? Let's start with how I got to this point. I was lucky to grow up at a time when it was not difficult for the child of a tenant farmer to make his way to the state university. And I was really lucky to go to the University of Iowa, where I could study under Professor James Van Allen, who built instruments for the first U.S. satellites. Professor Van Allen told me about observations of Venus, that there was intense microwave radiation. Did it mean that Venus had an ionosphere, or was Venus extremely hot? The right answer, confirmed by the Soviet Venera spacecraft, was that Venus was very hot, 900 degrees Fahrenheit. And it was kept hot by a thick carbon dioxide atmosphere. I was fortunate to join NASA and successfully propose an experiment to fly to Venus. Our instrument took this image of the veil of Venus, which turned out to be a smog of sulfuric acid. But while our instrument was being built, I became involved in calculations of the greenhouse effect here on Earth, because we realized that our atmospheric composition was changing. Eventually, I resigned as principal investigator on our Venus experiment because a planet changing before our eyes is more interesting and important. It changes will affect all humanity. The greenhouse effect had been well understood for more than a century. British physicist John Tyndall in the 1850s made laboratory measurements of the infrared radiation, which is heat, and he showed that gases such as CO2 absorb heat, thus acting like a blanket, warming Earth's surface. I worked with other scientists to analyze Earth climate observations. In 1981, we published an article in Science magazine concluding that observed warming of 0.4 degrees Celsius in the prior century was consistent with the greenhouse effect of increasing CO2. That Earth would likely warm in the 1980s, and warming would exceed the noise level of random weather by the end of the century. We also said that the 21st century would see shifting climate zones, creation of drought-prone regions in North America and Asia, erosion of ice sheets, rising sea levels, and opening of the fabled Northwest Passage. All of these impacts have since either happened or are now well underway. That paper was reported on the front page of the New York Times and led to me testifying to Congress in the 1980s. Testimony in which I emphasized that global warming increases both extremes of the Earth's water cycle. Heat waves and droughts, on one hand, directly from the warming, but also because a warmer atmosphere holds more water vapor with its latent energy, rainfall will become in more extreme events. There will be stronger storms and greater flooding. Global warming hoopla became time-consuming and distracted me from doing science, partly because I had complained that the White House altered my testimony. So I decided to go back to strictly doing science. and leave the communication to others. By 15 years later, evidence of global warming was much stronger. Most of the things mentioned in our 1981 paper were facts. I had the privilege to speak twice to the President's Climate Task Force, but energy policies continued to focus on finding more fossil fuels. By then, we had 2 grandchildren, Sophie and Connor. I decided that I did not want them in the future to say, Opa understood what was happening, but he didn't make it clear. So I decided to give a public talk criticizing the lack of an appropriate energy policy. I gave the talk at the University of Iowa in 2004 and at the 2005 meeting of the American Geophysical Union. This led to calls from the White House to NASA headquarters, and I was told that I could not give any talks or speak with the media without prior explicit approval by NASA headquarters. After I informed the New York Times about these restrictions, NASA was forced to end the censorship. But there were consequences. I had been using the first line of the NASA mission statement to understand and protect the home planet to justify my talks. Soon the first line of the mission statement was deleted, never to appear again. Over the next few years, I was drawn more and more into trying to communicate the urgency of a change in energy policies, while still researching the physics of climate change. Let me describe the most important conclusion from the physics. First, from Earth's energy balance, and second, from Earth's climate history. Adding CO2 to the air is like throwing another blanket on the bed. It reduces Earth's heat radiation to space, so there's a temporary energy imbalance. More energy is coming in than going out, until Earth warms up enough to again radiate to space as much energy as it absorbs from the sun. So the key quantity is Earth's energy imbalance. Is there more energy coming in than going out? If so, more warming is in the pipeline. It will occur without adding any more greenhouse gases. Now, finally, we can measure Earth's energy imbalance precisely by measuring the heat content in Earth's heat reservoirs. The biggest reservoir, the ocean, was the least well measured until more than 3,000 Argo floats were distributed around the world's ocean. These floats reveal that the upper half of the ocean is gaining heat at a substantial rate. The deep ocean is also gaining heat at a smaller rate, and energy is going into the net melting of ice all around the planet, and the land to depths of tens of meters is also warming. The total energy imbalance now is about 0.6 of a watt per square meter. That may not sound like much, but when added up over the whole world, it's enormous. It's about 20 times greater than the rate of energy use by all of humanity. It's equivalent to exploding 400,000 Hiroshima atomic bombs per day, 365 days per year. That's how much extra energy Earth is gaining each day. This imbalance, if we want to stabilize climate, means that we must reduce CO2 from 391 ppm parts per million back to 350 ppm. That is the change needed to restore energy balance and prevent further warming. Climate change deniers argue that the sun is the main cause of climate change, but the measured energy imbalance occurred during the deepest solar minimum in the record, when the sun's energy reaching Earth was least. Yet there was more energy coming in than going out. This shows that the effect of the sun's variations on climate is overwhelmed by the increasing greenhouse gases, mainly from burning fossil fuels. Now consider Earth's climate history. These curves for global temperature, atmospheric CO2, and sea level were derived from ocean cores and Antarctic ice cores, from ocean sediments and snowflakes that piled up year after year over 800,000 years, forming a 2-mile thick ice sheet. As you see, there is a high correlation between temperature, CO2, and sea level. Careful examination shows that the temperature changes slightly lead the CO2 changes by a few centuries. Climate change deniers like to use this fact to confuse and trick the public by saying, look, the temperature causes CO2 to change, not vice versa. But that lag is exactly what is expected. Small changes in Earth's orbit that occur over tens to hundreds of thousands of years alter the distribution of sunlight on Earth. When there is more sunlight at high latitudes in summer, ice sheets melt. Shrinking ice sheets make the planet darker, so it absorbs more sunlight and becomes warmer. A warmer ocean releases CO2, just as a warm Coca-Cola does, and more CO2 causes more warming. So CO2, methane, and ice sheets were feedbacks that amplified global temperature change, causing these ancient climate oscillations to be huge, even though the climate change was initiated by a very weak forcing. The important point is that these same amplifying feedbacks will occur today. The physics does not change. As Earth warms, now because of extra CO2 we put in the atmosphere, ice will melt, and CO2 and methane will be released by warming ocean and melting permafrost. While we can't say exactly how fast these amplifying feedbacks will occur, it is certain they will occur unless we stop the warming. There is evidence that feedbacks are already beginning. Precise measurements by GRACE, the gravity satellite, reveal that both Greenland and Antarctica are now losing mass, several hundred cubic kilometers per year, and the rate has accelerated since the measurements began 9 years ago. Methane is also beginning to escape from the permafrost. What sea level rise can we look forward to? The last time CO2 was 390 ppm, today's value, sea level was higher by at least 15 meters, 50 feet. Where you are sitting now would be underwater. Most estimates are that this century we will get at least 1 meter. I think it will be more if we keep burning fossil fuels, perhaps even 5 meters, which is 18 feet. This century or shortly thereafter. The important point is that we will have started a process that is out of humanity's control. Ice sheets would continue to disintegrate for centuries. There would be no stable shoreline. The economic consequences are almost unthinkable. Hundreds of New Orleans-like devastations around the world. What may be more reprehensible if climate denial continues is extermination of species. The monarch butterfly could be one of the 20 to 50% of all species that the Intergovernmental Panel on Climate Change estimates will be ticketed for extinction by the end of the century if we stay on business as usual fossil fuel use. Global warming is already affecting people. The Texas, Oklahoma, Mexico heat wave and drought last year, Moscow the year before, and Europe in 2003 were all exceptional events, more than 3 standard deviations outside the norm. 50 years ago, such anomalies covered only 2 to 3/10% of the land area. In recent years, because of global warming, they now cover about 10%, an increase by a factor of 25 to 50. So we can say with a high degree of confidence that the severe Texas and Moscow heat waves were not natural, they were caused by global warming. An important impact, if global warming continues, will be on the breadbasket of our nation and the world, the Midwest and Great Plains, which are expected to become prone to extreme droughts, worse than the Dust Bowl, within just a few decades, if we let global warming continue. How did I get dragged deeper and deeper into an attempt to communicate, giving talks in 10 countries, getting arrested, burning up the vacation time that I had accumulated over 30 years? More grandchildren helped me along. Jake is a super positive, enthusiastic boy. here at age 2.5 years, he thinks he can protect his 2.5-day-old little sister. It would be immoral to leave these young people with the climate system spiraling out of control. Now, the tragedy about climate change is that we can solve it with the simple, honest approach of a gradually rising carbon fee collected from fossil fuel companies and distributed 100% electronically every month to all legal residents on a per capita basis, with the government not keeping one dime. Most people would get more in the monthly dividend than they pay in increased prices. This fee and dividend would stimulate the economy and innovations, creating millions of jobs. It is the principal requirement for moving us rapidly to a clean energy future. Several top economists are co-authors on this proposition. Jim DePeso of Republicans for Environmental Protection describes it thusly: transparent, market-based, does not enlarge government, leaves energy decisions to individual choices, sounds like a conservative climate plan. But instead of placing a rising fee on carbon emissions to make fossil fuels pay their true cost to society, our governments are forcing the public to subsidize fossil fuels by $400 to $500 billion per year worldwide, thus encouraging extraction of every fossil fuel: mountaintop removal, longwall mining, fracking, tar sands, tar shale, deep ocean, Arctic drilling. This path, if continued, guarantees that we will pass tipping points, leading to ice sheet disintegration that will accelerate out of control of future generations. A large fraction of species will be committed to extinction, and increasing intensity of droughts and floods will severely impact breadbaskets of the world, causing massive famines and economic decline. Imagine a giant asteroid on a direct collision course with Earth. That is the equivalent of what we face now. Yet we dither, taking no action to divert the asteroid, even though the longer we wait, the more difficult and expensive it becomes. If we'd started in 2005, it would have required emission reductions of 3% per year to restore planetary energy balance and stabilize climate this century. If we start next year, it is 6% per year. If we wait 10 years, it is 15% per year. Extremely difficult and expensive, perhaps impossible. But we aren't even starting. So now you know what I know that is moving me to sound this alarm. Clearly, I haven't got this message across. The science is clear. I need your help to communicate the gravity and the urgency of this situation and its solutions more effectively. We owe it to our children and grandchildren. Thank you.
Keystone is the pipeline that is supposed to run down from Canada through the United States. And actually, it's probably going to go. I mean, I think the way the politics is going, it will be sanctioned, but it is the kiss of death for the world. So, and I will show you a video and argue why it is a terrible, terrible idea. Not just locally for the United States, but also for...
But in Canada, they're doing the tar sands,
right,
and it's really, I don't know how to say this, raping the environment.
Oh, absolutely.
I mean,
And the pipeline ends at a port,
right.
and so the oil is going to be shipped out of our country.
And it's going to go right to the aquifer.
Right.
That really
Oh, yeah, of course.
isn't
I mean, I will touch upon those issues, the Keystone as well as what is called fracking, which is the way the Obama administration has decided that this is the way to go about doing energy. In truth, the Obama administration has been as disappointing, if not more disappointing, than the Bush administration in its handling of energy. In fact, I'm actually pretty much a single issue voter at this point, and I will probably not vote this time around because I don't think it's useful to vote for these people. And that's the one thing that we all have is the right to vote in a democracy. But if you're given choices between the devil and the deep sea, what do you do? So so my hopes about the Obama administration were dashed basically simply on the count of how they handle energy, let alone all the other stuff. I can talk about this for. I talk about it for 6 months, so it's the difficulty for me is to figure out what to leave out and what to put in. But I think Hansen's talk covered a good bit of the global warming aspects and the causes for it. Next time I will try to connect it to the sources. So the main things are carbon dioxide. What we are pumping in the atmosphere is carbon dioxide, followed by methane, followed by nitrous oxide. These are the three main gases that are harmful as far as climate change goes. Carbon dioxide is mainly coming from fossil fuel sources, automobiles, any other power plants and so on. Methane is mainly coming from cattle. And nitrous oxide is mainly coming from cattle.
From cattle?
Cattle. Cattle are responsible, the production of cattle and the sustenance of cattle is now responsible for between 18 and 50% of all global warming gases produced on Earth.